Odysseus lands successfully on the moon. China is planning to build bricks on the lunar surface. James Webb finds the neutron star at the heart of supernova 1987A, and Blue Origin finally rolls out New Glenn. All this and more in this week's Space Bites. So the first big story was the successful landing of Intuitive Machines' Odysseus lander. And this was one of the most thrilling, action-packed landings I have been watching in many years of this. So what happened is this company, Intuitive Machines, built this Odysseus lander, and they were going to attempt a commercial landing on the surface of the moon. So there hasn't been a successful landing from the US in over 50 years. And so this was an attempt to not only demonstrate that a private company can land on the surface of the moon and sort of prove that they can carry commercial payloads to the surface of the moon, but also just a demonstration that engineers in the US have the capability to land on the moon. And this sort of sets the stage for the future return of humans to the moon. Last week, we reported that the spacecraft launched successfully on a Falcon 9, and we got some awesome pictures of the Earth as it was leaving with this fisheye lens. You can even see the SpaceX upper stage falling back from the spacecraft after it had given its kick towards the moon. It took about a week to get to the moon, and when it arrived, went into orbit, and then we went into the phase where it was going to attempt the landing. And this is where things got really complicated. The spacecraft was equipped with a landing system designed to allow it to measure the distance to the surface, to spot all of the potential hazards, and then it would autonomously choose the perfect landing site. But as it was getting prepared to land, we learned that this system had failed. And so its method of finding a safe landing site and knowing how far away it is from the surface of the moon was no longer available. And this was kind of the problem that doomed a previous Indian lander. You know, knowing the distance to the surface of the place you're trying to land on is critical. Here's where the story gets pretty amazing. On board the spacecraft is a payload for NASA, which was designed to test a new method of measuring the distance to the moon. And so when the engineers realized that their main system wasn't working, they were able to patch in the NASA system and then rely on that to relay telemetry as it was getting closer and closer to the lunar surface. Now, that caused a delay on when the landing was actually going to happen. It took an extra hour or so for them to hack together the system. I can't believe they did it that quickly. And so then they had this backup system as a way to measure their distance to the surface of the moon. And then they made their attempt. And that all went great. I mean, we got these regular communications, and we saw us getting closer and closer to the surface of the moon. And then it landed on the moon, and then nobody heard anything. And then we waited for several minutes as various antennae on Earth attempted to make a connection, be able to just confirm whether or not the lander was alive. And then finally, after it felt like forever, but it was about 5 minutes or so, we got a confirmation from the main antenna on the spacecraft that it was alive. But we don't really know much more than that. We're still waiting to find out exactly what happened. There's a bunch of cool things that should have happened, which we will find out soon, I hope. One is that shortly before it landed on the surface of the moon, it deployed a separate camera that it dumped out onto the surface of the moon. And it was designed to take a video of the spacecraft as it was landing on the moon, essentially deploying its own selfie stick. It's equipped with 6 NASA instruments as well as 6 commercial payloads. And we talked a bit about this last week. It's got a telescope on board designed to take wide-angle images of the Milky Way from the surface of the moon. It has an electrostatic system on board to test whether this is a way that will work for dust removal. So we're still waiting to hear whether or not the lander is safe, whether its instruments are working properly, whether we got that selfie image. So stay tuned for all of that. And landing on the moon has been tricky. There have been many attempts in the last couple of years, and we're running about 50-50. We saw landing failures from Israel's Space IL. We saw the Japanese iSpace team and the Russian Space Agency all failed their landings. And yet we saw successes with India's Chandrayaan-3, with the Japanese Space Agency's SLIM lander, although it was upside down, and the Chinese lander that sent a sample back home to Earth. So still, landing on the moon is very difficult, and it's not a hazard to be taken lightly. So congratulations to everyone from Intuitive Machines and NASA who sort of worked on this mission to try and get this down to the surface of the moon, and we will give you more information next week. China wants to build bricks on the moon. Now, China has been continuing to send missions to the moon. The most recent mission is the Chang'e 5 mission. This is the one that sent a sample back home. There are many more missions planned: Chang'e 6, Chang'e 7, and Chang'e 8. So the next two missions will be going to the moon, scanning regions around the southern pole, attempting to learn more about the permanently shadowed craters at the south pole of the moon. But the mission that I'm really interested in is Chang'e 8, which is scheduled for 2026. And the goal for this is to attempt various technologies that will try to use local lunar resources to do things. In situ resource utilization, ISRU, which is a term we've used a lot. And so, for example, one of the plans is they're going to have an instrument on board that is designed to scoop up lunar regolith and then sinter it, microwave it, solidify it, glue it somehow, and turn it into 3D printed objects. They just put out a call for some supplier within the country to provide this experiment. And the goal is that they need to be able to melt lunar regolith into usable parts at a speed of 40 cubic centimeters per hour. So if they're able to pull that off, then it'll show that you can use local resources on the moon to build stuff. So Chang'e 6 should be launching this spring. Chang'e 7 should be launching in 2026. And then after that, we should get Chang'e 8. And this is going to lead up to the Chinese having humans set foot on the moon by 2029, 2030. Perseverance has a problem with one of its instruments. So NASA's Perseverance rover has been exploring the surface of Mars. It recently had to say goodbye to the Ingenuity helicopter, but Perseverance is having a problem of its own with one of its instruments called Sherlock. So this is an instrument that Perseverance uses to analyze the material in rocks. It fires out a laser, it's able to vaporize a tiny little bit of rock and then be able to sense what the chemicals are in that rock to know what it's made out of. The problem is that it has a dust cover that's supposed to go in front of the instrument, and the dust cover has been opened part way. And this is bad for a bunch of reasons. One is that the dust cover is designed to stop that Martian dust from getting into the optics, which we know covers things, degrades solar panels. And in this case, you really don't want to get dust inside your optics. Dust! Dust! The other problem is that the door is opened halfway, and so it can't use its instrument because of the door being in the way. So NASA is trying to solve the problem. They've been sort of sending commands to try and make the door open, close, and they're gathering information. If it turns out that they're not able to solve this problem, all is not lost, because they do have sort of overlapping capability of the different instruments on Perseverance. And so there are several instruments on board Perseverance that can do spectroscopy to sort of learn what chemicals are in rocks. And so even if it is not able to use this one instrument, the rest of its instruments will be able to take over. And this is always part of the plan, expecting that it may get degraded. But, we've seen problems like this in the past, and this feels like the kind of thing that NASA is going to be able to solve. So we'll let you know when they fix it. Finally, Webb finds the neutron star at supernova 1987A. The closest supernova in modern history was supernova 1987A, and this went off in the Large Magellanic Cloud, which is about 170,000 light years away. So yes, I know it happened 170,000 years ago, and the light's been traveling to us, but other supernova were seen back 400 years ago, so we haven't seen a supernova nearby since this one. It's kind of amazing to think, this was more than 35 years ago. I remember when the supernova went off. And so when you get a large star dying in a supernova explosion, you should get some kind of compact object forming at the middle, be it a neutron star or a black hole. And so over the decades, astronomers were using better and better telescopes different instruments to watch the expanding wreckage of supernova 1987A, and the question was, would they be able to find the remnant left over? There's a pulsar that has been found in the Crab Nebula. Where's the neutron star in supernova 1987A? And finally, guess who? James Webb found the neutron star. But it didn't find it directly. It is an infrared telescope, and it's not really great at seeing incredibly hot, bright objects like neutron stars. You'd expect that's the kind of work that, say, an X-ray telescope would be able to see. What happened was James Webb was able to find a bunch of chemicals like iodine that were ionized, and they were very close to the center of the supernova. And when these chemicals are ionized, that means that there's some source of photons that is energizing the chemicals. And so that source has to be the neutron star embedded at the center of this cloud of material. And so Webb was able to confirm that supernova 1987A left behind a neutron star as a remnant. Case closed. The Kuiper Belt just goes on and on. NASA's New Horizons spacecraft has been exploring the outer solar system. It completed flybys of Pluto, gave us our first close-up images of Pluto and its moon Charon, and then it made a flyby of the Kuiper Belt object Arrokoth. It still has a lot of fuel on board, and so hopefully in the coming years it'll do another flyby of some other object. All of its instruments are doing great. Its nuclear power source is working just fine and should make it last into the 2040s. For the last couple of years, New Horizons has been examining its surroundings and looking at the kind of dust that it finds in its vicinity. It was expected that it should be getting to the outside edge of the Kuiper Belt, which is this region of icy objects in the solar system. And so the amount of dust should be declining. But instead, it's still been finding there's a lot of material in its surroundings. And these particles are caused by micrometeorites impacting Kuiper Belt objects throughout the belt and then causing debris, which means that it's still in the Kuiper Belt. So what would explain this? Well, one possibility is that the Kuiper Belt is a lot bigger than anyone was expecting or had observed. The other possibility is that it actually passed out of the Kuiper Belt and is now moving into a second belt that is farther out. So more research is necessary. As I mentioned earlier, because New Horizons is doing so well, it's expected to live into the 2040s. And the hope is that it will eventually get out of the region that is dominated by dust from the solar system and move into a region that's dominated by interstellar dust. And this is really important because when you think about future missions, if we want to go and send spacecraft to other stars, we have to understand what is the terrain like? What kinds of dust will we expect to find as we make these journeys between star systems? And so hopefully New Horizons will be able to tell us how much dust is out there, how big the particles are, and how much damage we might expect some spacecraft to experience as it's trying to fly from star to star. And if you're interested in the Kuiper Belt, I recently did a fascinating interview about how Eris and Makemake, which are two dwarf planets in the region, probably have geothermal activity and some kind of cryovolcanism. There's a lot to learn about the Kuiper Belt, so check out that interview. Every week, we do a vote where you tell us what you thought was the best story of the week. And the winner this week was the discovery that even tiny Mimas has some kind of subsurface ocean. So thank you, everybody, for voting. We post this poll within about 24 hours of when we do Space Bites into the community tab on our YouTube channel, so you can go and find it there. But also if you're just scrolling through YouTube, just scrolling, feeding the algorithm, and you see the vote show up, go ahead and vote, and we will tell you the results next week. Now, the best way to make sure that you're going to see the vote is to subscribe to the channel and click the notifications bell. So do that. Space-grown drugs return to Earth. So this week, a capsule landed in Utah. And in the capsule was not an asteroid sample, but in fact, it was a crystal grown in space. Now, the mission was sent to space by a company called Varda Space Industries, and they were testing how various antiviral drug crystals grown in space compare to Earth-based crystals. We know that when you grow crystals in space, when they're in a weightless environment, they can be very pure. And we've seen examples like fiber optic cables can be grown in space, and they are optically perfect compared to the
Mission
kinds
liftoff
that
from
you can
Space
use
Shuttle
on
Discovery,
Earth, and so
taking the space station
they
to
are
full
better
power
for
for
communication
full
systems.
science.
And the question is, for certain kinds of chemicals, drugs, that require growing crystals, will you get a better output if you do this in space? So the drug is an antiviral called ritonavir, and it's used to treat HIV, AIDS, and hepatitis C. And so the hope is that if it's grown in space, it will be more effective. And if that's the case, then you can imagine like some facility in space on a space station that is growing crystals and then returning them to Earth and providing benefits to people here on Earth. The mission launched back in June 2023. It was only supposed to last for a month, but they were having trouble getting approval from the U.S. Air Force to land at the Utah test facility. So they had to wait until they got approval, and when they did, then they were finally able to have the capsule return to Earth. So maybe space-grown drugs will be the next industry that uses space. Speaking of sample capsules landing in Utah, we finally know how much material was sent back from OSIRIS-REx when it visited asteroid Bennu. We had a couple of rough estimates that were running around the internet, but NASA was able to finally open up the sample capsule and carefully weigh everything that they had gathered, and it came out to 121.6 grams, which is almost 4.3 ounces of rock and dust. Now, the goal was 60 grams of material, so they got more than double that. And the plan now is to preserve about 70% of this material, put it into deep, cold storage, and then it'll be used by future scientists. And NASA does this a lot. Like back with the Apollo missions, when they brought those samples back to Earth, they put a lot of it into this very cold, very safe storage, and knowing that there would be better instruments in the future that could analyze the samples. And so we still see fresh research that's getting done with the Apollo samples. And so you can imagine future generations of scientists getting access to these OSIRIS-REx samples to try and understand the early solar system with lab equipment that we just can't even imagine yet. Also, about 200 researchers around the world will get tiny little pieces of sample material that they can start studying today. Now, just for comparison, the Hayabusa 1 mission, which went to asteroid Itokawa, brought home less than a gram. The Hayabusa 2 mission that went to asteroid Ryugu brought about 5.4 grams. And the Stardust mission, which went to Comet 81P, brought home about 1 gram. So 121 grams, that's quite a bit. I hope you're enjoying the news, but if you want to learn more about the cool stories, the research that's being done, you should definitely check out all of the interviews that I do with people behind the scenes, people who actually work on the missions, the science teams who are making these discoveries. These interviews are like about an hour long. We go into incredible depth. I know that this audience is very technical. They understand space things, so we can go deep in and really understand and answer a lot of questions that we have about next frontiers in space and astronomy. So if you're skipping them, you shouldn't. They're a lot of fun. Check out the interviews. We finally see New Glenn. All right, it feels like it's been forever. And Blue Origin has been teasing us that they're working on a rocket, I think, called New Glenn. Well, apparently it was true all along. And so this week we got a chance to finally see what the New Glenn looks like on the launch pad. They brought it out from the factory and then tilted it vertical on launch pad 36 at Florida's Cape Canaveral. So now they're going to do a series of tests where they practice vehicle integration, transport, ground support, and launch operations. But this version of New Glenn doesn't have the BE-4 engines. They're going to test those separately at a site in West Texas. After these tests are done, then they're going to test filling it with propellant, with pressure control, vehicle venting. And after that, I'm sure we can expect static burns, full tests for the entire duration of how long it would take to go to orbit. So if all goes well, we should see a New Glenn launch in 2024. The pressure's on. They have customers, commitments. It's time to launch this rocket. Euclid begins its mission. Now, we've been reporting on the European Space Agency's Euclid mission. They launched last year, and then they've gone through a big test phase. We saw some sample images coming back from the satellite. But finally, it has begun its full science campaign. Now, the full campaign is going to take a total of 6 years. And what it's going to do is Every 70 minutes, it's going to shift position and take a long duration image of the sky. Then it's going to move to another location and take another one. And in each one of these images, it's going to gather 50,000 galaxies using two separate instruments. One in infrared, which will help astronomers know what the galaxies are made of, and then one invisible, so they can see what the shapes of the galaxies are. And then from that, they'll be able to map the amounts of dark matter and dark energy in the universe as they are pushing galaxies apart, as they are distorting the shape with gravitational lensing. And hopefully, we should get like the best measurements of both dark matter and dark energy that we've seen so far. And over the course of the full 6 years, it's going to take pictures of billions of galaxies. So we're going to get the first data release probably in spring 2025 after it's completed about 15% of its mission, and then there'll be a much larger release in 2026, and then after 6 years we'll get that final release. And this is going to feel very similar to the Gaia data releases. We've gone through 3 data releases so far, waiting for that next big data release. All right, I'm going to talk some more about landing on the moon, but first I'd like to thank our patrons. Thanks to Stephen Filler-Munley, Paul Rohrbach, Abe Kingston, H. Weiler, Dougie Stewart, Stephen Krasaki, David Richards, Mark Hansis, Joel Yancey, Antonio Lofilara, Dustin Cable, Vlad Chiplin, Monzo, George, David Gilton, Andrew M. Gross, Jeremy Mattern, Josh Schultz, and Jordan Young, who support us at the Master of the Universe level, and all of our other supporters on Patreon.
Approaching minimums.
I've got to say, watching the Intuitive Machines landing coverage was fantastic. They did a great job, both of giving up-to-date information about how the landing was going, but also bringing in simulations of what, where the spacecraft was and what the landing terrain would look like. And then they went and did interviews with people both at NASA and within the Intuitive Machines crew. And this was like the first time that they had done this kind of a presentation, and I was really impressed. And I'm a connoisseur of this kind of thing, and so I hope other people are taking notes when they provide coverage of the lunar landing. It's like when these things are landing on the moon, when these missions are happening, we're all around the world, and we are watching with our computers, and we wish we could be there in the control room to know everything. We want to see photographs from every angle. We want to know what's going on all of those screens as data is being sort of sent back and forth between the team. We want to understand. And I think hopefully as the technology gets better, as people learn how to put on a good show, we'll be able to see more and more. And when you think about what's going to happen when those first people set foot on the moon,
are throttling down as the orbiter passes through the area of maximum pressure on the vehicle.
Like, did you watch those first moon landings back in 1969? It was before I was born, but people remember it fondly. Being there, being for this shared moment when humanity accomplished something amazing. And in the coming years, we're going to accomplish many more amazing things. And I really hope that all the space agencies, all the engineers, the people working on these projects can bring us along for the ride. All right, we'll see you next week.